On screen, two dashboards are answering the same question. What was revenue this week? The left dashboard says $480,000. The right dashboard says $572,000. The difference is not a charting problem. It is a modeling problem. Somewhere below the dashboards, a join multiplied rows, a metric definition drifted, or a freshness assumption broke. This is the problem production analytics engineering solves. Now the screen shows the full path. Raw e-commerce sources enter the warehouse. DBT models turn those raw records into staged tables, intermediate transformations, facts, and dimensions. Tests and freshness checks guard assumptions. Metrics become governed product APIs. A semantic layer exposes those definitions to business intelligence, embedded analytics, and AI systems. Lineage connects every output back to the source data that created it. The three panels on screen separate the work. Data engineering moves and stores reliable raw data. Business intelligence presents answers to users. Analytics engineering sits between them. It labels the boxes, checks what is inside, builds trusted shelves, and writes the map every dashboard can reuse. The output is not just CQL. The output is shared business, meaning that survives production pressure. The table on the left has one row per order. The table on the right has one row per order item. When we join them and sum order revenue after the join, the same order revenue appears once per item. The red total is inflated. This is why dashboards lie. Before you aggregate, state the grain. One row per order, one row per customer, one row per order item, or one row per day are different promises. On screen, source declarations mark upstream warehouse tables. Each SQL model uses ref calls to depend on another model. DBT reads those refs and builds the graph in a safe order. That graph is the first lineage map. It tells you what must run first, what depends on what, and which downstream models can break when one model changes. The stack on screen shows why mature DBT projects use layers. Staging models stay close to one raw source and clean names, types, and source-specific quirks. Intermediate models hold reusable transformation logic that is not ready for business users. Marts expose facts and dimensions with clear grain. Metrics sit above the marts, so revenue, active users, conversion, and retention are reused instead of redefined in every dashboard. Here, the screen turns hidden assumptions into visible checks. A not null test says every order must have an order ID. A unique test says customer keys should not repeat in a dimension. A relationship test says each order must point to a known customer. Freshness checks ask whether the upstream source is current enough. A contract card records owner, grain, columns, and change rules. Quality is not a cleanup sprint. It is an engineering workflow. The timeline shows an incremental model using a simple watermark. It only processes records newer than the last run. That is fast, but the late arriving order event in red is older than the watermark, so the model misses it. The corrected version uses a safe look-back window and repeatable backfill thinking. Incremental models are performance tools, but production teams design explicitly for late data and reprocessing. The metric card on screen is for net revenue. Notice that it includes more than a SQL expression. It has an owner, a grain, a base measure, allowed dimensions, filters, freshness expectations, and a change policy. This is why the course treats metrics as product APIs. When a dashboard, an app, or an AI answer asks for revenue, it should call the same governed definition. The semantic layer diagram shows business concepts above the physical tables. Entities describe things like customers and orders. Measures describe aggregatable values like gross revenue. Dimensions describe ways to group results, such as country, channel, or order date. Metrics combine those definitions into governed questions. MetricFlow uses the semantic model to generate SQL at query time, so different tools can ask the same question without copying different SQL. The highlighted path starts at a change source column. It flows through a staging model, an intermediate model, a fact table, the net revenue metric, a dashboard, and an AI answer. This is blast radius analysis. Table lineage is useful, but column and metric lineage are more useful when you are reviewing a risky change. The question is not only what table depends on this, the question is which decisions depend on this meaning. The incident board shows a wrong revenue alert. The first step is not guessing. Scope the impact. Is the issue one dashboard or every consumer of the metric? Then check freshness, failed tests, recent pull requests, and lineage. The timeline narrows the likely failing model. A useful incident review does not stop at fixing one query. It adds prevention work, a test, a contract, a review rule, or better monitoring. The pull request on screen changes one model, but the safe check is not only that model. CI should compile the project, run tests on changed and downstream models, validate docs and contracts, and require extra review for metrics and semantic definitions. This is the analytics version of production deployment discipline. Broken models and silent metric changes should not reach users by accident. The final screen brings the pieces together. In the full CodersSecret course, learners design a raw-to-mart model map, DBT-style staging and fact models, metric specs, semantic definitions, lineage worksheets, incident debugging notes, and a Capstone architecture they can explain in a portfolio. The goal is not to memorize tools. The goal is to reason clearly about trusted production analytics.